Hi everyone, it's Christy and I post weekly calculus videos so that I can help you with your calculus learning. So if you haven't subscribed already, make sure to subscribe so that you can see weekly videos of various calculus topics that'll help you with your learning of calculus. In this video, we're going to look at a region and find the exact area of this region. Now notice it's this irregular region, and calculus helps us find the area of this region. And for that, I find it fascinating. So let's take a look. We are going to let R be the region bounded by the functions y equals, or f of x equals negative 3x squared, and g of x equals 2x squared minus 5x as shown in the diagram below, and we are going to find the exact area of region R. In case it helps, I'm going to write what each of these functions are. So f of x is negative 3x squared. That would be a parabola opening down, so that's going to be this parabola right there, and then g of x, notice because the a value of 2 is positive, that's a parabola opening up, so this function over here is going to be g of x, and I want to find the exact area of that region R. Like I said, for this we're going to use calculus, and specifically we're going to use an integral. Now it appears that these two functions intersect right here and right here, and it looks like the point 0, 0 and the point, let's see, 1, negative 3, but let's just make sure. If I were to plug in the x value of 0 into f of x, I would get 0 for the y value, and also to g of x, so that does confirm that the intersection point is at 0, 0. Now if I were to plug in 1 into the f of x function to find f of 1, I would get negative 3. Also, if I found g of 1, I would also get negative 3. So once again, that confirms that those are in fact my intersection points. If they weren't so easily found like that, you would either need to set the functions equal to each other and find those intersection points using algebra, or you would want to plug both of those functions into your graphing calculator and calculate the intersection points. The reason I need this is because when I find the area, I'm going to use an integral, and I'm going to add up an infinite amount of teeny tiny rectangles from the very first x value of 0 all the way to the end of the region, which has an x value of 1. And to find this area, what I would need to do is to find the area of one of these teeny tiny rectangles. I would need to know the height of that rectangle, and the height would be this distance right here. To find that height, you would need to take the top function, which we labeled as f of x, minus the bottom function, which we labeled as g of x. So just to start, let me go ahead and write out that we are taking f of x minus g of x, or top minus bottom, and then we need to have our little dx to represent the width of that rectangle. So we really have height times width, or if you think about base times height, which would be the area of a single rectangle, and the integral symbol means we're going to sum up an infinite amount of those rectangles. Let's go ahead and plug in our functions of f of x, which is negative 3x squared, and our function g of x, which is 2x squared minus 5x. Notice I put parentheses there. That is definitely a mistake that a lot of my students make, is they forget to put the parentheses around the second function, because when you go to simplify, you will need to distribute that negative to both terms to get a simplified function of negative 5x squared plus 5x. I anticipate that if I were grading some papers right now, I'd see a lot of minus 5x for students who forget to distribute that negative. From here, we're ready to integrate. So I'm going to use the power rule, which tells me to add 1 to the exponent and divide. And let's evaluate this function between the x values of 0 and 1. So I'm first going to plug in 1 into both of them, and then I'm going to subtract what I get when I plug in 0, but notice because both of them are being multiplied by an x term, that would just be minus 0. So I'm going to write it, or usually you don't have to if it's just minus 0. Let's get some common denominators because we are going to solve this by hand. And when I add those together, I get a final answer of 5/6, which is the area of this shaded region R. All right, everyone, I hope you found this video helpful in your calculus learning to find the area between two curves. And isn't that fascinating? Calculus helped us find the area of this irregular region. I think it is excellent. If you haven't subscribed already, make sure to subscribe and give it a like so that you can see weekly calculus videos so they can help you with your learning of the subject of calculus. I hope you have an excellent day, and we'll see you in the next video. Bye, everyone.